There's a problem though with assuming that each colony came from a single bacterial cell. And so we'll see that instead of saying the number, how many bacteria there were in the original sample, instead the expression that's used to describe bacterial concentration in a sample is not bacteria per mil, but colony forming units per mil. So here's why, and here's the difference between saying bacterial cells per mil and colony forming units per mil. All right. So again, if here's a nutrient agar plate, and each one of these dots represents a single bacterial cell, you know what will happen if you incubate this plate is that each one of these bacterial cells should start dividing and dividing and dividing, and it's each clump that you see here that's basically what colonies are. Right? So for the most part you can assume that each colony came from a single bacterial cell, but sometimes something like this might happen. You might have a situation where two bacterial cells just end up landing really close to one another on a nutrient agar plate. And so whenever this happens, when they divide and divide and divide, you'll see that this colony here, it actually arose from two cells that were right next to each other, not a single bacterial cell. So whenever you see a colony on a plate, what we're trying to say is that you can't automatically assume that it came from a single bacterial colony. So because you don't know if it came from a single bacterial cell or from several cells really close to one another, what we say is that each colony came from not a single cell but a colony forming unit. And here's the definition of colony forming unit. And so now that we have this terminology down, colony forming unit, or CFU, we can figure out then the concentration of CFU per mil in the original sample. And you can do that again by taking a look at these results. Even though you set up a whole bunch of plates and then incubated them all, you're not going to end up counting every single one of them. Instead, what you're going to do is just really quickly identify which one of these plates gave you the most countable, manageable number of colonies, and that's the one you're going to count. And so by definition, the most countable is the one that has between 30 and 300 colonies on it. So from just eyeballing these plates in this particular example, this is the one that fits the bill. Right? So again, if we're going to try to figure out the number of CFUs, colony forming units per mil in the original sample, you just count the one plate that produced between 30 and 300 colonies, and that's the one you count. So how about if we go ahead and run through it then. So it turns out that if you count the colonies on this plate, there are 29 colonies on there. That's close enough to being between 30 and 300. To use this number to figure out the number of bacteria or CFU per mil in the original sample, here's what you do. So the first thing you do is not figure out the number of CFU per mil in the original sample, but instead figure out the CFU per mil in the sample that produced the plate that you ended up counting. All right? So you can use this number to figure out the concentration of CFU in this sample by actually just looking at it. All right? You can see that when you took 1/10 of a mil out of this sample, that 1/10 of a milliliter contained 29 CFU. So that's the concentration then in this sample. There are 29 CFU per 1/10 of a mil in this particular sample. Again, conventionally, people don't put decimals in fractions, so you can get rid of this decimal by multiplying top and bottom by 10. And when you do that, that gives you 290 CFU per mil, right, in this sample. So these are just two ways of saying the same thing. There are 290 CFU per mil in this particular sample. Once you've figured out the concentration of CFU in this particular sample, the one that produced the plate that you ended up counting, you can then use that number in order to figure out the CFU per mil in the original sample. And here's how you do it. you'll need this number here, 1 over 100. So remember that this tells you that this sample is 1/100th the concentration of this. In other words, the original sample is 100 times more concentrated than this. So if you know that the bacteria in here are 100 times more concentrated than the bacteria in here, and you know that the concentration, the actual concentration of bacteria in this sample is 290 CFU per mil, then you should be able to figure out that all you'd have to do then to figure out the concentration of bacteria in here is to multiply this number by 100, right? Because this is 100 times more concentrated than this. To say it in the technical terms, so what you do to this number then is you multiply it by the inverse dilution factor, right? So the dilution factor of this is 1 over 100. The inverse of 1 over 100 is just 100, right? So that's 100. And when you do that, that should give you this number here, 29,000 CFUs per milliliter. That's the number of colony-forming units there were in the original sample. Now, when you plated your dilutions, you were asked to label your plates like this. And by doing so, that basically will give you a quick and easy method of figuring out the dilution, or I'm sorry, in figuring out the concentration of CFU in the original sample. Basically what these numbers represent is the total dilution factor on each one of the plates. So in other words, if again you incubate the plates and you see something like this form on the plates, you would just quickly eyeball the one that gives you between 30 and 300 colonies, and that's the one that you end up counting. And then in order to figure out the concentration of CFU in the original sample, you would just then take the colonies, or the number of colonies on the most countable plate, in this case it would be this one, and then multiply it by the inverse total dilution factor which you were given. And when you do that, right, in this example again there were 29 colonies on that plate, the inverse total dilution factor is well, the dilution factor is 10 to the minus 3, so the inverse of that would be 10 to the 3, and that'll give you the same thing, 29,000 CFU per mil in the original sample. So again, by telling you, by being given these numbers, it makes it really easy for you then to figure out the concentration of CFU in the original sample. But if you know how to do it like this, so you won't necessarily be given all the time these total inverse dilution factors before you plate stuff. So if you know how to figure out CFU per mil using this method that we showed you before, that'll work for you every single time, even if you're not given the total dilution factors.